All right. Welcome, everyone, to the Marshall W. Allworth Planetarium. My name is Jessica. I am the director, but will not be in charge of your show tonight. Since it's the second Wednesday of the month, we are joined by the Arrowhead Astronomical Society, who will be giving the show this month. We've got Jim, who's going to be talking about his experience with the solar eclipse. Yeah, that's all I gotta say. It's all yours.
Oh, that was quick. Okay. So how many people went to see the solar eclipse? All right. Did you see totality? You were able to see it. Where were you at? Missouri. Okay. And then who else? I know, Tom, you went, and anybody else? Well, this is kind of a talk about that eclipse experience. It's just one of the most awesome things, I think, that you can possibly see. And would you all agree who did get to see it? Yeah, it's just an amazing thing to witness. The sun takes on just this completely different look when it's black with the corona around it. So we'll talk about that. I encourage any of you, if you got a question, whatever, just feel free to kind of blurt it out, interrupt. I'm happy to stop and answer that, so that you can kind of get the most out of this presentation. So it was 1 month ago today, we had that solar eclipse, April 8th. 2024 was the eclipse, and we got a month later here now. So let's see. There we go. Okay, so here's a map of the eclipse path. So let's see here. So this has actually got two eclipses on here. This was an annular eclipse that happened last October. I'll touch on that a little bit. And then this is the total solar eclipse that happened just this past April. It started out here in the Pacific Ocean, went across Mexico, across Texas, and then Arkansas, Missouri, and what is that, Ohio up there? And
sorry, real quick. We do not allow synchronization here. Whoever just opened that is just either bring it to me or just hang on to it, and I will. Don't mess with me. All right, sorry, Jim.
Okay, yeah. All right, so I went across this. This was the path that it followed. And eclipses are relatively easy nowadays to predict. So they can calculate all the geometry and know exactly where and when the things will happen. Of course, we're way up here in Duluth, and then we traveled, my wife and I traveled all the way down here to Texas, right here in the Dallas area. So I got a brother-in-law that lives there. We went to visit my brother-in-law, and we're hoping to see the eclipse from there. So here's a kind of a picture. We loaded up the vehicle. I had tripods, telescopes, all kinds of things like that with me to go on down there. Here's Dallas. My brother-in-law is right about here in McKinney, Texas. So we went down there to watch this. The forecast was looking bleaker and bleaker as we got closer to the day. It's like, oh no, it's not gonna, this can't happen. So on Sunday before, so that was on a Monday when we had the eclipse, the Sunday before, my wife got a text message from some friends of hers who are going up here to see where this yellow circle is. This is Ouachita Hills, Arkansas. I checked what the forecast was there, and it was like, oh, 0 to 20% cloud cover, so that looked good. So we went and visited them up there, so that worked out pretty good. So this is where we went to see the eclipse. And the forecast was looking quite promising. So what makes a solar eclipse? Maybe some of you know, but we'll just review what the cosmic geometry is looking like. So you got the sun way out in space. You got the moon, which orbits the Earth. And then the moon always has a shadow passing behind it. When the sun, or when the moon passes by the sun, which it does once a month, that's what we call new moon. We actually had new moon yesterday. The shadow of the moon yesterday did not touch the Earth, but last month it followed right, or fell right upon the Earth, and that was the path that I showed you earlier. So here you can kind of see this area right in here. If you were to kind of draw your lines where you got a touching the sun, touching the moon, and going down the Earth, there's a spot here on the Earth where it's completely in the moon shadow and you can't see any of the sun at all. When that happens, you get totality. If you're outside of the that zone, this area here, you see the moon block some of the sun, but not all of it. So that's called a partial eclipse. Every total eclipse starts as a partial, goes into totality, and then comes back out as a partial. Here in Duluth on that day, we had about a 70%. So the moon went across the sun, but it wasn't aligned well enough to cover the entire sun. So we had a partial eclipse here. Unfortunately, from talking to some of the people here, it was very cloudy and I think even raining on that Monday. So it was hard to even tell anything was happening. So this is kind of the geometry here that generates an eclipse. When you're in totality, that's when you actually hit darkness. Now, it's not complete darkness, as dark as night, but it's dark enough that stars can come out. Although I didn't see any stars here, but I was able to see Venus and Jupiter quite easily because they're fairly bright up there in the sky. During the partial phase, when the sun is partly blocked, that is, you still got a blinding amount of light from the sun. So you have to wear eclipse glasses during that time. But once totality starts, during that few minutes, we had 4 minutes where I was at, 4 minutes of totality, it becomes eye safe. You can take those glasses off. If you're using a telescope, you can take the filter off, and you can actually look at the sun during that time because you're not seeing any of the surface of the sun. So moving along, this is kind of a few pictures I shot of that eclipse, the April 4 one. These are some of the partial phases. So this might here be around 50% or perhaps just a little bit less is covered by the moon. And then here you can see we're probably in the 80 to 90%. And here was just a little sliver was left of the sun poking out. That little sliver is still too bright. You need to wear your solar eclipse glasses to even look at that. And here's a picture. This is my wife here, and you got the nice looking solar eclipse glasses on. Let's see here. So you probably all remember these. You can get them. They were selling them all over the place. I think Menards was selling them for like $1 a piece or something like that. You could get these all over the place. They have some really dark they have really dark, they absorb 99.99%. So they let through 1/100,000th of the light. So if I put a flashlight behind here like this, you can kind of see, you can just barely see the LEDs. I don't know, can any of you see that further back? It blocks most of the light. So anyway, you need these for looking at the partial phase. I want to emphasize that because it's not worth hurting your eyes over when you're looking at an eclipse, no matter how spectacular it is. So there's other ways you can look at the partial phase too. So here is another thing that I set up. So this was a mask or like a cardboard sign that I made, and I punched a bunch of little holes in there. So if you look at this, when the sunlight passes through, you can kind of see, well, you can kind of barely see. I actually put 4/8/2024 on there, and then I have a map of the state of Arkansas, and there's a little spot right here. This is where we were located. And what I did is I punctured holes through this so you can kind of see, let's see, can you kind of see how the sunlight or the light goes through that? So this actually made a sign of little eclipsed suns, and you can kind of see over here, there's a close-up on the left-hand side there. Right here, you can kind of see all these little crescent suns. So it actually was spelling out 040, or what is that? 4/8/2024, and then it had the map of kind of a map of Arkansas right there, and then it has Amity. Amity is where we were. Amity was the little town that was right there. So that's something you can do to actually kind of make a keepsake for the eclipse event. So that's kind of like a pinhole projector. You get little tiny images of the sun. You can actually get this too. I didn't do this time, and I wished I would have. I keep forgetting. During a partial phase, the sunlight going through the tree leaves, if there's little openings, you'll actually get little shapes of the sun in the shadow of the tree. So you can kind of see that way too. It would look like this, but it would be under a tree. So that's something else you can do. I'll have to try and get that on a different eclipse. But this is something you can see in a partial phase. So anytime we have a partial, and partial eclipses happen here relatively frequently, maybe every couple years or so, you could try to look at it that way. Here's another means to look at the eclipse. So this is called projection through a telescope. So I have a telescope here. There's no filter on it, and it's shining onto a white cardboard here, and you can kind of see the crescent sun there. And so you can watch the phases progressing that way also for an eclipse. I had that on a clock drive just so that people could kind of walk up. And where we were, it was an academy, so there was it was a high school age, so there was a number of high school students there and some staff, and they were enjoying coming and looking at that. And then also had a telescope set up. So this is a 6-inch reflector telescope, and we were looking at the sun through that. Here I had a filter on the front, so you can kind of see this thing right up here. I'll show you what that looked like. So this is kind of a solar filter that I could put on the front of the telescope. And so again, this is kind of like that those eclipse glasses. This lets 1/100,000th of the light. When you do this, you can look through the telescope at the sun, and it's actually safe to look at for your eye. And I will routinely do that just anytime, because right now there's actually some amazing sunspots on the sun. Some great big ones. They've kicked off some big flares that might give us some northern lights in the next couple of days. It's possible. Those are hard to predict, but that might happen, so keep your eye peeled for that. But this will let you look at the sun at any time for that. And your eclipse glasses, now that the eclipse is done, that doesn't mean you have to throw your glasses away. If you were to look at the sun today or tomorrow, there's a sunspot group on it so big that you can see it with your eclipse glasses on, just looking at the sun with your eyes. You don't even need a telescope. You'll see it as a spot up there. So if you still got your pair handy, try taking a look at the sun through those. Tomorrow, I think, will be clear too. All right. So when you look through the telescope, though, at the sun, it requires that filter. You cannot look at the sun otherwise without that until totality hits. So now, that was before the eclipse. Now we're getting into like a couple minutes before the eclipse. So there's a few things that you can see. Shadow bands. So shadow bands are something I've read about. I was able to see them on this eclipse. So what shadow bands are is there's just little very faint shadowy waves just moving across light surfaces. So like where I was, there was a sidewalk, and they'd put out a piece of white cloth on the ground too, and you could see these ripples just flowing across. That's turbulence in the atmosphere, and the thin shaft of sunlight coming through was actually making these brighter zones and darker zones, and you could see those just moving across. It was pretty cool to see that. Bright stars started to come out. So about 15 minutes before the eclipse hit totality, I looked up and it's like, oh, wow, I could see Venus just right up there, even though the sky was still fairly bright. It was darkened enough that Venus came out. And then Jupiter came out a little bit after that. I didn't see any stars. I was hoping to see some stars also. I wasn't able to see any stars during this eclipse. Part of it, maybe we did have some cirrus clouds up. There's some thin clouds that might have affected being able to see some of that stuff. Also, when the sun gets very thin like that, the shadows get sharper also. Although, I'll have to be honest, I didn't notice. I was too kind of excited about what was going on. I didn't actually pay attention to that. Let's see, now here's a picture of the eclipsed sun, and then this was Venus that came out. So that was one of the pictures I shot there. So a few seconds before totality hits, these are some of the things that you can see. So Bailey's beads happen. That's where sunlight is just passing through between the mountains and valleys on the edge of the moon. I did not see Bailey's beads. This was a picture that somebody else took, and I got it off the internet. And just one of the last things that happens is you got the diamond ring. So here's a picture of the diamond ring. So this, a little bit of the filter is off the camera at this time. We've still got the glaring amount of sunlight coming through, but you can see the corona at the same time also. So that's called the diamond ring effect. And this corona here, what we're looking at out here, this faint, misty looking view, that's the sun's atmosphere. Very, very hot hydrogen gas and various other gases there. So totality arrived. We're in Amity. This is a picture here. You could kind of see where we were. We got totality here. We were in a school. This is kind of the school grounds. So off here in the distance, you can see this This is the boys' dormitory sidewalk coming up like this. Um, Totality is just beyond belief in terms of when you look up at that and you see that sun, it's just something that is hard to, you can't really describe it either. It's just that blackness of the sun with the corona around it. Just being able to see it is just so amazing. And part of what I'm hoping is that some of you will say, yeah, I got to go see one of these someday. From that, it's totality is not anything like a partial. Even a 99%, if there's just a little sliver, that's still completely different than totality. You need to get yourself, if you have a chance to, get yourself under the path of the shadow to see that. So this was a wide angle view here. And then, oh yeah, I also shot, while I had the camera set up, I had the filter on there. So during the partial phases, I shot a number of images of the sun. And so the Earth is rotating, the sun is moving across the sky, so it naturally gets spaced. So I took exposures as we got closer to totality, and then exposures as it was coming out. So you could kind of see how the sun was moving across the sky, and you can see the shape, how the moon is blocking the view of the sun. Here we're probably at 50%, and then as we go on, it gets thinner and thinner, and then pow, everything shows up, the corona and all that. And then it starts coming back out. Where I was, the eclipse was 4 minutes. It just went by like that, you know. It's one of the shortest amounts of time in your life when you're just trying to take that in. It just goes so fast. So now here's a picture with a telephoto lens of the eclipse sun. So you can kind of see the corona all around here. And I took this area here and I kind of zoomed in on it. You could see these prominences and stuff there. You could see that through a telescope. These prominences, just to give you an idea, these would probably be 3 or 4 Earth diameters tall. You know, if you were to put Earths there, they would probably be like that. You know, the Earth would be quite small compared to that. So these are great big plumes of hot sun, hydrogen gas, just supported by the sun's magnetic field. They aren't a flare. A flare is a much more energetic event. These are just kind of a regular thing that happens routinely on the sun. For those of you who went, were you able to see any of the prominences on the sun when totality hit? Yeah, you were able to see one? Yep, this one right here. Yeah, I could see that one too. It just stood right out. It was just bright. I didn't see this one with my eye, looking up at it, but I did see this quite easily. Tom, did you say you saw this one over here also? Oh, you didn't? Okay. Yeah, this had even like some structure. That had some structure and stuff in it. So during totality, I had the telescope set up, and we had the filter on there, but it's in the partial phase. But once totality hit, I took the filter off. It was then eye safe at that time, and that view of the sun through the telescope was just incredible. It looked great just looking up with your eye, but to me, when I looked at it through the telescope, it was just bigger. I could see more detail. It still seemed to have the fineness and stuff. Now, I'm colorblind, so I don't get to see the colors and stuff. People describe that there's pinkishes and things like that, pinkish color and stuff in there. I don't see any of that. It's just kind of whitish to me, but it was still just, the view was just amazing. I brought binoculars along. You could use binoculars to look at the sun during totality. But I forgot to take them out. I didn't even get them out of the car. I just forgot to even do any of that. It's just, everything just gets so busy then. There's just so many things I forgot to do that I wanted to do. But still, got to see some of this. Let's see here. So here's another picture of totality. This shows this prominence here a little bit better. This is a longer exposure. So depending on how long the exposure is, will show how much corona that you can see up there. Oh, okay. This was a view, one of my coworkers, he went to Illinois to watch the eclipse, and he set up one of those 360 video cameras. And so he caught that. And so this is a video that shows kind of the approaching shadow of the sun, of the moon coming towards you, coming over the thing and then passing over. Jessica, could you play that video? So you could kind of see the shadow approaching and then passing over. Were you able to notice that? Play it one more time if you would, Jessica. So now it's approaching. There it hit the sun. And now we're kind of under the shadow zone. So you can look out past the perimeter, the edge of that shadow, and you can kind of see still the brightness of the sky further away. Now this is accelerated. This is faster than what real time would be. This is like 30 times faster. But he said, I think he didn't say, that he could actually see it approaching. I was going to look for that. Another thing I forgot to look for while I was at the watching this. Like I said, it's an amazing event, and you kind of lose track of things. But it's definitely worth going to see. So let's see here. We'll move on. Oh, this is another picture here. So I got this off the internet. The International Space Station was flying over during the eclipse. So this is a picture shot from the International Space Station. So you can kind of see the shadowed area here. This is when it was passing over kind of Maine into Quebec and what is that, Newfoundland or New Brunswick? That's what it was up there. So this is a picture of that. And you can kind of see the shadow. You have to get yourself under that shadow to see totality. If you're standing over here, you're not going to see it. You have to actually get yourself into the shadow to see this. And it's definitely worth taking the effort to do that. I'll just keep saying that here. So, so totality. The shadow is maybe, it depends on the geometry of how far the moon is away from the sun at the time, from the earth at the time the eclipse happens, how far the earth is from the sun when the eclipse happens. These things can affect various things. So a shadow is I think can be around 150 miles across. In the 2017 eclipse, I went to see that one also. That one was a shorter eclipse. So the moon was probably further away and was smaller in our sky, and it didn't block the sun as completely. That shadow was a little bit smaller. So the shadow, I don't think it got as dark during that particular eclipse as it did during this one, because the boundary where there's still got sunlight is closer to you. Let's see. The speed of the shadow moving across the earth is around 1,500 miles per hour. So it varies depending on whether it's at the edge or kind of in the middle of the earth or going towards the other edge. It varies, but it's moving along pretty fast. Typically, they last a few minutes. I think the longest eclipse, depending on how the geometry works out, can be 7 minutes or so. And it can be as short as just a few seconds, or no eclipse. We'll have an annular eclipse. We don't get totality. They happen about every 18 months or so, but that's kind of, it can be several months on one side or several months on the other side with that. And I'm going to show you a map with some coming eclipses and the dates that they're happening. On average, the entire Earth will have the shadow going over it every 370 years. I don't know when the last time one hit Duluth was, or when the next one is scheduled to hit Duluth. So more likely than not, for all of our lifetimes, if you want to see one, you'll have to travel someplace. So now, other types of eclipses. I was talking about the distance thing. So the moon orbits the Earth in an elliptical orbit. And so sometimes it's a little bit closer, and sometimes it's further in that orbit. And see this picture up here. Whoops. This picture right here. This is a picture of the moon, two pictures of the moon at different times with the same photo setup. You can see how the size varies. This is called a perigee moon, or you'll hear it on the news described as a supermoon. That's what that is. And then this is an apogee moon, or when it's its furthest. So it can be substantially different in apparent size in the sky. So if it's smaller, it might not actually be big enough to cover the sun. If it's bigger, it covers it with extra margin. It takes a while to travel over it. So when we have a annular eclipse, the moon is further from the Earth, and so the shadow actually gets kind of wiped out somewhere up above the surface of the Earth. Nobody on Earth gets to see a total eclipse, but you do get to see an annular. And so what you see is this, the moon shadows part of the sun, but there's a bright ring around the outside. That you have to use eclipse glasses to watch. And here's a picture of an annular eclipse that happened in October. It went across that southern part of the United States, and my brother lived in Albuquerque, so I went and visited him during the eclipse. And so this was a sequence picture I shot of all the sun going into eclipse, and then we have totality there, or not totality, that's the wrong word, annular, and then coming back out. And this is kind of zoomed in on that region. You can see this is just kind of a ring right here. That's a blinding bright ring, and you can see the phases moving in and the phases coming back out for that. So an annular eclipse is never eye safe. You always need to have some kind of eye protection to watch this. And then there's one other type of eclipse that happens. This is a lunar eclipse. So solar is when the shadow of the moon falls on the Earth. You have to be under that shadow to see it. A lunar eclipse is when the shadow of the Earth, or when the moon passes through the shadow of the Earth. And so if you can see the moon while it's passing through, anybody who can see the moon on the back side, on the night side of the Earth, if you can see the moon, you can watch a lunar eclipse. Lunar eclipses are really interesting too. Different than a solar. So here you can kind of see the shadow being projected back and the moon passing through that shadow. So right here, this is kind of what a lunar eclipse looks like. So you've got the full moon. So a lunar eclipse always happens at full moon by definition because it's opposite from the sun. If the sun is on one side of the Earth, the moon's on the opposite. That's the definition of a full moon. So it always happens at full moon. You can see here, this is the shadow of the Earth starting to cover the moon. Here it's getting further, and then here it gets into totality. And it takes on this red color. The red color is the result of all the sunrises and sunsets happening around the Earth at that instant of time. You get that reddish color. You can see it in the clouds and in the sky at sunrise or sunset. Some of that reddish light continues off into space. It's bent by our Earth's atmosphere into the shadow of the Earth. And then if the moon passes through, it gets feebly illuminated by that red light. That's the combined effect of all the sunrises and sunsets happening at that instant in time on the Earth. So that's a lunar eclipse. These happen more frequently. We'll get one of these like every year to 2 years, somewhere in there. We had one where a sequence where we had 4 lunar eclipses like 6 months apart. And we got to see, I think, all of them here, although weather can frequently cause a problem for us especially. Okay, here's a map showing some upcoming eclipses. So this is for the 2020s. So this is in our decade. Here's the one we just had right here, April 24. So that's passing there. Here's the annular that went there. So that was last October. But the next one that's going to happen is this one right here, October 12, 2026. The eclipse is going to start way up here in Siberia, travel across the Arctic, and it's going to come down across Greenland, Iceland, and it's going to end in kind of Spain here and off in the Mediterranean. So this will be around sunset when that one happens. There'll probably be a number of people traveling to go see something like that. And maybe people waiting out here on a boat or something to see it too. We have another one here, this one right here. This one is August 2, 2027. This one, I've already seen advertisements for that one, and some of them are already sold out. So this eclipse goes across Morocco and northern Africa, and then it goes across Egypt, and it hits right across Luxor, Egypt. So a lot of people are going to go to Luxor in Egypt. You know, that's one of the old temples there, to actually watch the total eclipse from there. Good chance of clear skies anywhere along that region there. And then there's just a whole bunch of other eclipses that are occurring during that. For us, if you don't want to travel far, our next solar eclipses for the United States are going to be these right here. So right here, this August, what is that, 23? 2044. So about 20 years from now, there's an eclipse that kind of starts up, oh, it starts here in Greenland, and it kind of arcs through this northern area, this upper Canada, and this is all pretty remote and very hard to get to. And then it comes down through Canada into Montana, or here we are, we've got Alberta and Saskatchewan, it looks like, and then um, hits Montana and the end of North Dakota. So I think this will be a sunset eclipse right here. So this is something that if anybody had a mind to, that wouldn't be too hard to travel over into this area to see that. And then we have another good one right here. This one here. This is August 13, or is that a 12? That's an August 12 again, 2045. So the next year, the United States gets another eclipse passing right across there. So this is going to go across most of the United States. So there's another one for you to put on your calendar, 21 years from now. And then, of course, there's some all over in other places around there. That is it. Any questions or anything that I can answer, or any comments anybody has? Or yeah, Randy. Where I was, there, I was kind of in the school grounds, and there wasn't anything close, so I didn't notice anything with the animals. It was cool though. So the morning started out with a coolness to it, and it stayed cool as the partial eclipse progressed into totality. As soon as totality ended and the sun started coming back out and I was putting my stuff away, it got hot really fast. And it's like, oh, wow, that eclipse really made it feel nice. Now, I don't know if you heard anything, Tom or Mike or your other two there. Did you see anything with animals? Or? Yeah, yeah, that happened to me on so many things. There's like afterwards, like, oh, I wish I would have done this, or I wish I would have done that, and well, I'll have to get that at the next one, I guess. Mm-hmm. Yeah.
Hey Gerardo, yeah, we got on the internet, where the groups are going to be, and we found one that seemed like it was going to be much quieter. There's no entertainment or anything like that. But I can just remember it. Yeah, that 4 minutes you were just kind of in a trance. You know.
Yeah.
We had a telescope, you know, so we had people wanting to look at it. But I just remember it getting real quiet. Everybody was just pretty much in a trance, you know, watching. It's probably about 100 people maybe there, something like that. So yeah, that's pretty cool. I mean, yeah, it's really hard to kind of describe, you know, such a profound experience.
Yeah. Yeah, it was, I think everybody kind of has that same thought, you know, I had plans and you just lose it. When that, as it gets close, you just lose it and it's like, but it's worth it, I mean.
So for about a month or something, so we were ready. We were on totally on the learning curve, you know, so we were
Yep.
struggling to keep, you know, we had a track in the sun, left that much
Mm-hmm.
knowledge. It was fun.
Yeah. Okay, Tom, yeah.
I just want to make one comment about these English classes. This is very important. I actually saw someone I was with actually did this very, very briefly. So I'm honestly not to do this. English classes are only good for naked eye vision. Okay? You described this big sunspot. You might see that with your naked eye and think, oh, maybe I can go get my pair of binoculars. Binoculars and have my English classes behind it.
Oh.
You cannot do that because you always have to have correction of the light in front of the eyes. So binoculars will concentrate that light and really burn right through, just like a magnifying glass will burn if you hold up in the sun and focus it, burn right through those glasses. So don't do that.
Yeah, don't do that.
Glasses are only for just your unaided eye. No options.
Excellent comment. Yeah, you can't stress enough how safe you need to be while you're doing this. But it's not a safety that's unattainable. You just kind of got to watch a couple things and then follow it. But highly worth going to see.
The other thing I'll say too is that these are fantastic photographs, but just seeing it with, and those of you that did see this, pictures don't do justice
Yeah.
to what you actually saw with your eye, or what you see through the telescope, what you see through the pictures. Your eye can handle varying degrees of brightness and brightness so much better than even what a modern camera can do. So that's what makes it just such a special event. It's really one of nature's greatest things.
Okay. All right. Well, thank you.